So the area of solutions is considered open or unbounded if there are an infinite number of solutions. But if you introduce a third inequality and now close off the open-ended side, you have a closed or bounded set. So the area of solutions is considered closed or bounded if there are a finite number of solutions. Only the points within these three lines in the shaded area are the solutions to this system. So a bounded set is the overlap of solutions for all three inequalities, A, B, and C. So for A, it must be the points greater than or to the right of this line. For B, this line, it's the points greater than. And for C, it's the points less than. So that is how you wound up with the bounded set in here. So we'll create one from scratch when we walk through an example in a moment. But first, let's discuss when we have no set for our system. If the areas of solutions for all three inequalities do not overlap, then there is no set of solutions. So two overlapping areas will not do it. We need all three to overlap. So let's say we had inequalities A, B, and C, but let's say B and C are parallel. If that is the case, then there's a chance that we will end up with an empty set. So if the solutions to the left of this line or above this line solve B, and the points below C solve C, then it doesn't matter if the points to the left of A or to the right of A are looked at. We're only going to have areas where one or two of the solutions can be found, but not all three. So in this space here, those would be the solutions to only A. Here, the points to A and B overlap, but not C. And here, the points to A and C overlap, but not B. And if we go back and look at the points less than A, here we have the points that overlap A and B, but not C. And here we have the points that overlap A and C, but not B and C. So B and C never overlap. Doesn't matter if we're looking at the points less than A or greater than A. And thus, for this system, we would have no solutions. So let's walk through an example from the beginning. You'll be asked to find the solutions by graphing the system of inequalities. Inequality A, x is less than 4. Inequality B, y minus x is greater than or equal to 1. Inequality C, y minus 5x is less than negative 2. So the process for graphing this system will be similar to a 2x2 system. So step 1, isolate y on the left side of inequalities B and C. There's no y in A, so we'll skip A for now. So for B, we'll start by adding x to both sides, giving us y is greater than or equal to x plus 1. So we'll write inequality B with this expression. And we'll repeat the process for C. So we'll add 5x to both sides, giving us y is less than 5x minus 2. So we'll rewrite C with this expression. And now we want to create value tables for A, B, and C so that we can sketch all three lines. So we'll start with A. Step 2, change inequality A to an equation. So we change the less than sign to an equal sign. And since x is always going to be equal to 4, in the value table, x will always be 4. So we'll change y from negative 1 to 0 to positive 1. So the 3 points in this value table are 4, negative 1, 4, 0, and 4, positive 1, which will be a vertical line where x is 4. And now we want to create a value table for B. So step 4, change inequality B to an equation. We changed the greater than or equal to sign to an equal sign. And now we have y is equal to x plus 1 So we can create a value table for equation B. So when x is -1, y is equal to -1 plus 1, which is 0. So the first point in the value table is x is -1 and y is 0. When x is 0, y is equal to 0 plus 1, which is 1. So the second point in the value table is 0, 1. And when x is +1, y is 1 plus 1, which is 2. So 1, 2 is the third point in the value table. You then put that value table to the side and create a value table for C now. So step 6, change inequality C to an equation. So we change the less than sign to an equal sign. And now step 7, record 3 xy values for equation C in a value table. So when x is -1, y is 5 times -1, which is -5. -5 minus 2 is -7. So -1, -7 is the first point in the value table. When x is 0, y is 5 times 0, which is 0. 0 minus 2 is -2. So when x is 0, y is -2. And the third point, when x is +1, y is 5 times 1, which is 5, minus 2 gives us 3. So the third point is x is 1, y is 3. So now that we have value tables for A, B, and C, we'll be able to sketch each of the lines. But we first want to find the 3 vertices before we sketch the lines. So these are the 3 places where these 3 lines will cross each other. So we'll have to find the vertex of A and B, and then we'll find the vertex of A and C, and then we'll find the vertex of B and C. So it's the same process, just 3 different times. So don't be overwhelmed by the number of steps that it winds up taking to complete this question. So step 8, substitute x into equation B. So we're finding the vertex of A and B. In A, equation A is x is equal to 4. So we plug in that x into B here, giving us y is equal to 4 plus 1, which is equal to 5. So when x is 4, y is 5. So that's the vertex for A and B. Now we want to find the vertex of A and C. So since x is equal to 4, we'll substitute x into C here and then solve for y, giving us 5 times 4, which is 20. 20 minus 2 is 18. So where x is 4 and y is 18, that's where A and C cross. So now we have 2 of the vertices. And now for the last vertex, we want to do B and C. So we want to subtract equation C from equation B and then solve for x. So we have y is equal to x plus 1 and y is equal to 5x minus 2. When we subtract them, we get y minus y, which is 0. X minus 5x is negative 4x. 1 minus negative 2 is positive 3. And now we can solve for x. So we'll subtract 3 from both sides, giving us negative 3 is equal to negative 4x. And now to negate the coefficient negative 4, we divide both sides by negative 4, giving us x is equal to 3/4 or 0.75. So now that we know the x coordinate for the vertex where B and C cross, we can now substitute x into either equation B or C and then solve for y. So if you plug this into B, you would get 0.75 plus 1, which is y is equal to 1.75. Or you could have plugged it into C, which should give you 5 times 0.75, which is 3.75. And then 3.75 minus 2 is equal to 1.75 as well. So the vertex for BC is where x is 0.75 and y is 1.75. So now we have all 3 vertices where the lines cross each other. and we have a value table for all three lines, so we can sketch A, B, and C. So now we can go ahead and begin to graph. So step 16, plot the vertices. So starting with AB, the first point is where x is 4 and y is 5. Plot the point. For vertex AC, it is where x is 4 and y is 18. Plot the point. And for vertex BC, it's where x is 0.75 and y is 1.75, so we plot the point. And now step 17, plot the points from the value table of equation A. So the first point is 4, -1. Plot the point. The second point is 4, 0. And the third point is 4, 1. So now with these 3 points, we can sketch the line for A. So we draw a dotted line through the points. And now step 19, plot the points from the value table of equation B. So the first point is -1, 0. The second point is 0, 1. And the third point is 1, 2. And now with these 3 points, you can sketch the solid line for B. So step 20, draw a line through the points. And it's solid since it's or equal to. And now step 21, plot the points from the value table of equation C. So the first point is -1, -7. Plot the point. The second point is 0, -2. And the third point is 1, 3. And now with these 3 points, we'll be able to sketch C. So step 22, draw a dotted line through the points. And it's dotted since it's less than but not equal to. And now we can shade the areas for each respective inequality. So step 23, shade the area to the left of inequality A. So inequality A is here. We shade the area to the left of it since we have less than. And now for B, step 24, shade the area above inequality B. So we go to B, it's greater than, so the solutions will be above this line. So we shade the points above that line. It'll continue in this direction. And now step 25, shade the area below inequality C. So you go to C here. And since it's less than, you shade the points below that line. And once you've shaded all 3 of those areas, you see the only area where all 3 overlap is on the inner part of these 3 points. So this would be the solution to this system. All right, so this is what we call a bounded or closed system of inequalities. And this is how you would find the solutions by graphing the system. Let's wrap up the chapter by having you complete a few practice questions. Find the solutions by graphing the system of inequalities. Question number 1, inequality A, x is less than 5. Inequality B, y plus 2x is greater than or equal to 6. Inequality C, y minus x is less than 3. Question number 2, inequality A, x is less than 2. Inequality B, y minus 3x is less than 1. And inequality C, y plus 2x is greater than or equal to -3. Pause the video, answer these questions, and then press play when you are ready to begin. Question number 1, step 1, isolate y on the left side of inequalities B and C. So for B, we have y plus 2x is greater than or equal to 6. And we'll subtract 2x from both sides, giving us y is greater than or equal to negative 2x plus 6. So we'll write inequality B with this expression here. And we'll repeat this process for C. Y minus x is less than 3. We'll add x to both sides, giving us y is less than x plus 3. So we'll write inequality C with this expression here. And now we want to create value tables for A, B, and C. So step 2, change inequality A to an equation. So that would be x is equal to 5. And now step 3, record 3 xy values for equation A in a value table. So since x is always going to be equal to 5, all 3 points x will be 5. So we plug in negative 1, 0, and 1, since this line will exist at all 3 of these y values. So this would be the value table for A. And now we want to create a value table for B. So step 4, change inequality B to an equation. So we change greater than or equal to equal to. And now we plug in negative 1 for x, and we see y is equal to negative 2 times negative 1, which is positive 2, plus 6, which is 8. So the first point in the value table is negative 1, 8. When x is 0, we get y is equal to negative 2 times 0, which is 0, plus 6 gives us 6. So the second point in the value table is 0, 6. And when x is positive 1, we get negative 2 times 1, which is negative 2, plus 6 is positive 4. So the third point in the value table is 1, 4. And now that we have a value table for B, we want to create a value table for C. So step 6, change inequality C to an equation. So we change the less than sign to equal to. And now we plug in negative 1 for x, showing us y is equal to negative 1 plus 3, which is positive 2. So the first point in the value table is negative 1, 2. The second point, when x is 0, y is 0 plus 3, which is 3. So 0, 3 is the second point in the value table. And when x is 1, y is equal to 1 plus 3, which is 4. So 1, 4 is the third point in this value table. And now that we have the value tables for A, B, and C, we can sketch all 3 of those lines. But before we do that, we want to find the 3 vertices where these 3 lines cross. So we want to find where A and B cross each other. We want to find where A and C cross each other. And then we want to find where B and C cross each other. So for A and B, equation A is x is equal to 5. So we can substitute x into equation B here and then solve for y, step 9, giving us negative 2 times 5, which is negative 10, plus 6. Negative 10 plus 6 is equal to negative 4. So when x is 5, y is equal to negative 4. So that's vertex AB. And now for AC, step 10, substitute x. X is equal to 5 into equation C, x plus 3, giving us y is equal to 5 plus 3, which is 8. So vertex AC is where x is 5 and y is 8. So now we have 2 of the vertices. And now we want to find the vertex where B and C cross each other. So we write those 2 equations out. And we'll subtract equation C from equation B so that we can cancel out our y's, giving us y minus y, which is 0. Negative 2x minus x is negative 3x. And 6 minus 3 is 3. To solve for x, we'll subtract 3 from both sides, giving us negative 3 is equal to negative 3x. And to get rid of the coefficient negative 3, we'll divide both sides by negative 3, giving us x is equal to negative 3 divided by negative 3, which is 1. And now that we know x, we can substitute x into either B or C. We're trying to find the vertex of BC, so we plug it back into either one of these. And then step 15 will allow us to solve for y. So if you choose to plug it into x into B, you would get negative 2 times 1, which is negative 2. Negative 2 plus 6 is positive 4. So the vertex for BC is 1, 4. You also could have plugged in x is 1 into C instead, giving you y is equal to 1 plus 3, which is 4. So you get the same vertex either way. So now we have all three vertices, AB, AC, and BC. And we have value tables for A, B, and C. So now we can plot our vertices, plot our lines, and then shade our areas to find the solutions. So step 16, plot the vertices. The first vertex for AB is 5, negative 4. The second vertex is AC at 5, positive 8. And the third vertex for BC is positive 1, positive 4. So we plot the vertices, and now we're ready to plot the points from the value table of A. And the first point is 5, negative 1. The second point is 5, 0. And the third point is 5, 1. And now with these 3 points, we can draw a dotted line to create the line for inequality A. And it's dotted since it's less than, but not equal to. And now step 19, we can plot the points from the value table of equation B. And the first point is negative 1, 8, 0, 6. And the third point is 1, 4. And now with these 3 points, we'll be able to sketch the line for inequality B. So step 20, draw a line through the points. And it's a solid line since in the inequality it's greater than or equal to. And now, step 21, plot the points from the value table of equation C. So the first point is negative 1, 2. The second point is 0, 3. And the third point is 1, 4. And now with these 3 points, we'll be able to sketch the line for C. So draw a dotted line through the points. And it's dotted since it's less than but not equal to. And now we want to begin shading in the areas. So step 23, shade the area to the left of inequality A. It's a vertical line. In the inequality, the solutions are less than 5. So along the x-axis, less than or the smaller values are to the left. So we shade those points. Now step 24, shade the area above inequality B since it's greater than. So you go to B, and now you shade the points above that line. And now step 25, shade the area below inequality C since it's less than. So you go to C, and you shade the area below it. And we see the only area where all 3 overlap is the inner part of these 3 points. So this would be the solution to question number 1. Let's now wrap things up by taking a look at question number 2. Inequality A is x is less than 2. Inequality B, we have y minus 3x is less than 1. And inequality C, y plus 2x is greater than or equal to negative 3. So step 1, isolate y on the left side of inequalities B and C. So we'll start with B, and we'll add 3x to both sides, giving us y is less than 3x plus 1. So we'll rewrite inequality B with this expression. And now repeat the process for C. Y plus 2x is greater than or equal to negative 3. So we subtract 2x from both sides, and we'll rewrite inequality C with this expression. And now we want to create value tables for A, B, and C. So step 2, change inequality A to an equation. And since x is always going to be equal to 2, all 3 points in this value table, x will be equal to 2. And since it's a vertical line, we'll use negative 1, 0, and 1 for our y coordinates. So this is the value table for A. Now let's create a value table for B. So step 4, change inequality B to an equation. So change the less than sign to equal to. Now we plug in 3 values for x. So when x is -1, y is equal to 3 times -1, which is -3. -3 plus 1 is -2. So when x is -1, y is -2. When x is 0, y is 3 times 0, which is 0, plus 1, which is 1. So when x is 0, y is 1. And our third point, when x is 1, y is equal to 3 times 1, which is 3, plus 1 is 4. So 1, 4 is the third value for this value table. And now we want to create a value table for C. So step 6, change inequality C to an equation. So we change greater than or equal to equal to. And now we plug in 3 values for x. So when x is -1, y is -2 times -1, which is 2. 2 minus 3 is -1. So when x is -1, y is -1. When x is 0, y is equal to -2 times 0, which is 0. 0 minus 3 is equal to -3. So when x is 0, y is -3. And when x is 1, y is -2 times 1, which is -2. -2 minus 3 is -5. So 1, -5 is the last value in this value table. So now we have value tables for A, B, and C. So we want to find the vertices for AB, AC, and BC. So for AB, equation A lets us know x is equal to 2. So we could substitute 2 into equation B here. So that would give us y is equal to 3 times 2, which is 6, plus 1, which would give us 7. So y is equal to 7. So x is 2, y is 7 is the vertex for AB. Now we want to find the vertex for AC, so we want to substitute x into C here, giving us y is equal to -2 times 2, which is -4, minus 3, which will give you -7. So when x is 2, y is -7 for vertex AC. And now we want to find the vertex for BC, so we write those two equations out. And since we can't cancel out our x's with addition or subtraction, we'll focus on our y's. And we have positive y for both, so we'll subtract equation C from equation B, giving us y minus y, which is 0. 3 minus -2x is positive 5x. 1 minus -3 is positive 4. And now we'll subtract 4 from both sides, giving us -4 is equal to 5x. We'll divide both sides by 5, giving us x is equal to -4 over 5, or x is equal to -0.8. So now we know the x-coordinate for this vertex, so we could substitute x into either equation B or C and then solve for y. So if we plug it into B, here, we get 3 times -0.8, which is -2.4, plus 1 would give you -1.4. So vertex BC is where x is -0.8 and y is -1.4. But you also could have plugged in -0.8 into C. So if you did that, you should get the same value for y. -2 times -0.8 is positive 1.6. Minus 3 gives you -1.4 for your y. And with that, you have all 3 vertices where AB, AC, and BC cross each other, plus the value tables for A, B, and C. So let's start graphing these. So we'll start with the vertices. Step 16. So AB is where x is positive 2 and y is positive 7. AC is where x is positive 2 and y is -7. And BC is where x is -0.8 and y is -1.4. And now we can sketch the lines by using our value tables. So step 17, plot the points from the value table of equation A. Our first point is 2, negative 1. Our second point is 2, 0. And our third point is 2, 1. And with these 3 points, we can sketch A by drawing a dotted line through the points. And it's dotted since it's less than but not equal to. Step 19, plot the points from the value table of equation B. Our first point is negative 1, negative 2. Our second point is 0, 1. And our third point is 1, 4. And with these 3 points, we'll now be able to sketch B. So step 20, draw a dotted line through the points. And it's dotted since it's less than. And now, step 21, plot the points from the value table of equation C. So the first point is negative 1, negative 1. The second point is 0, negative 3. And the third point is 1, negative 5. And now we have the 3 points that will allow us to sketch C. So step 22, draw a line through the points. And now we can begin shading in the areas. So step 23, shade the area to the left of inequality A. The solutions are less than 2, so less than goes to the left. And now for B, shade the area below inequality B since it's less than. So you go to B and you shade in the points below that line. So we see A and B overlap here. And now step 25, shade the area above inequality C since it's greater than. So you go to C and you shade the points above that line. And the only place where all 3 solutions overlap is on the inner part of these 3 points. So this would be the solution to question number 2.